As you dig deeper into mathematics, you realize that it's so much more than just solving equations or graphing lines. Yes, we do those things in math, but really, it always goes back to patterns. Every equation, every line is really a pattern, and when you discover the pattern, well, you can dig deeper. You can start to analyze, you can start to apply. There's some special patterns in math. As you can see from today's statement, apparently we can analyze a pattern using arithmetic or geometric sequences. Now, there may be a few words in here that you're not sure of. How about the first word we see there, arithmetic? Well, first off, that is actually how you pronounce it, not arithmetic, but in this kind of topic, it's arithmetic. Well, there's also geometric. Now, again, that you know the word geometry, but it turns out that geometric is really just a certain kind of pattern. How about this word here, sequence? Do we realize that a sequence is really just a fancy word for a pattern of numbers that are together? So could we find the next term in a sequence? How about the 20th term? If you look at this first problem, maybe just simple inspection, you can tell that the numbers are changing. They're changing by how much? That's right, by adding 4. But that's our first observation, that the numbers are changing by adding. And of course, we have that specific number 4. So it makes for an easy problem. Sure, I can find the next term. I probably could find the next 5 terms if I wanted to. But what if I wanted to find the 20th term? I don't know if I want to actually count out or list the next so many 15 or so terms. Let's make some observations. The first thing we saw, that's right, we saw that the terms were changing by addition or subtraction. So when terms are changing by addition or subtraction, it turns out that that specific amount of change is called the common difference. And it perhaps is the most important part of this sequence. We also typically label the common difference with a capital D, but I want to make sure you realize that for this particular problem, it was 4 or plus 4. So when you have this type of pattern, we say that it's an arithmetic sequence. Now again, what's a sequence? It's really just a list of numbers that are in a particular pattern, and when it's arithmetic, we see that it's changing by addition or subtraction. Now, there is a formula that describes an arithmetic sequence. It can look a little overwhelming at first, but let's just get into it. I think you'll find out that each of these symbols, each of these variables actually represents something that should make sense. First off, a sub n, well, that's going to be whatever term we're trying to find. We typically call that the nth term. Now, if you're still a little confused when I use the word term, that's really just the number that we see in the pattern. So do I see the 5th number? Do I see the 10th number? How about the 20th number? But we don't call it a number, we call it a term. And so a sub 1 would actually be the first term. It's the first term in your sequence. And then are you catching on? The letter N is really just describing the term position. Again, do I have the 5th term? Do I have the 20th term? The letter N is the actual position. And here's this D, we've said already, but it perhaps is the most important thing. So let's say it again, it's the common difference. Remember, that's how much the numbers are changing, of course, by addition or subtraction. We already found the 5th term. Remember, it's 19. But let's use this formula for the first time to kind of show how it works. So if I'm trying to find the 5th term, that really means I'm trying to find a sub 5. Now I know what the first term is, right? I can go back up to the sequence and see that it's the number 3. But what term am I trying to find? Yeah, the 5th term. So we're going to fill in a 5 for n. It's always minus 1. And remember that common difference was 4. So now I have created for myself a little math problem that I can kind of solve using the order of operations. Of course, we're going to do the parentheses first, so 5 minus 1 is 4. But now I can multiply the 4s to be 16, and eventually 16 plus 3, bingo, is 19. And that means that a sub 5, my fifth term, is 19. Ready to find the 20th term? Yeah, we don't really know what it is yet, but we can plug into our formula. We kind of can say that we're finding a sub 20. What's going to go next? That's right, it's the first term. Now I'm trying to find the 20th term, so I'm going to fill in a 20 for n. It's always minus 1. And my common difference is still 4. Got yourself a little math problem, and I can just do the order of operations. Of course, that's going to be 20 minus 1 is 19. 19 times 4 is going to come out to be 76, and 76 plus 3 is 79. So my 20th term, without listing all those terms, I can be sure is 79. Ready to try some on your own? Well, if you were in the classroom, that's exactly what I would expect you to do here. So look at this first one. You're trying to find the 50th term. See if we can kind of help each other get started. What's the first thing that we're going to need to get here? Yeah, that's right. It's that common difference. And most of the time, students will just kind of notice the common difference is how much the numbers are changing. But it would be great if we label it as D. And how much are they changing? That's right. We're adding 10. Once you have that common difference, you're ready to set up your formula. Go ahead and try it. At this point, you should pause the video. You should be actually trying to set up this problem. If you're just waiting for me to do it, yes, I am going to show the answer in a moment, but pause the video, see if you can set it up, and even move on to the next problem. All right, so we're trying to find the 50th term. I'm going to need the first term. Once again, it's the 50th term I'm trying to find. Always minus 1 and times 10 for this problem. That's your common difference. Now be careful, we have 10 in two places here. The first 10 is the first term, but the second 10 is actually the common difference. 49 times 10, that's 490, plus 10 more is 500. This kind of makes sense. If you're trying to find the 50th term, it would be the term 500. Now, have you already tried this last example? Same thing, if you're in the classroom, you'd actually want to be thinking about this, maybe be talking to your neighbor. Yes, I am going to go over it in a moment, but pause the video. There's something a little different in this problem. The common difference is actually, yeah, it's a negative number. The numbers are changing by 5, but they're actually going down by 5. So yes, I can have a common difference that's negative. How about the rest of the problem? Is it going to behave the same way? I'd like to think so. You're finding the 10th term, so that's a sub 10. I need my first term. You're trying to find the 10th term. It's always minus 1. And then I'll, of course, very carefully use negative 5. So this is going to come out to be 6 plus 9 times negative 5. 9 times negative 5, of course, is negative 45. But negative 45 plus 6 is negative 39. If you think about it, you're going down by negative 5 each time. So by the time I get out to the 10th term, I'm going to be way down here at negative 39. At this point, since you're doing the lesson through the video, I'd like you to just pause and just kind of summarize what's something that's true about an arithmetic sequence, what's something that maybe you're not sure about. This would be something we would discuss in the classroom before we move on to the next side of the paper. All right, so we have another sequence, but it doesn't look like it's changing in the same way as an arithmetic. How can we describe the way that is changing? That's right, by multiplication. Yeah, look, each number is times 3 the previous number. Times 3, 4 times 3 is 12, 12 times 3 is 36. Of course, I can get to 108, and 108 times 3, use a calculator if you need to. Yeah, that's 324. So what do we observe here? What are some things that are worth sort of noting here? Well, the terms are changing. Yeah, they're changing by multiplication or division. You'll find out that we could think of it as a division problem. But when terms are changing by multiplication or division, the amount that they change by is called a common ratio. Now, are you familiar with the word ratio? Yeah, a ratio actually is a division problem. But that common ratio, the amount that they change by, is labeled as R. And again, for this particular problem, just to make sure we're clear, that means that R would equal 3. Now, sometimes it can be a little harder to find a common ratio. So as a little bit of a hint here, a little help in case the problem gets tricky, you can always find that common ratio by taking the next term divided by the previous term. Again, if the numbers are perhaps a little tricky, you can actually do a division problem. If you just test it for this one, you could take the next term, whichever one you want to use. You could actually use 108 and divide it by the previous term. Yeah, divided by 36. Well, yeah, that would come out to be 3. And you could test that for any of the numbers, and you would find that common ratio. We'll talk about that a little bit more, but I'm sure you're not surprised to hear me say that when numbers are changing by multiplication or division, we call it a geometric sequence. Now, it's a different formula. If you look at this formula, you can see that it's got some distinct differences. I would hope that you would say that the main difference, the one main difference, is that we actually have an exponent. So a geometric sequence uses an exponent. And when you learn a little bit more about mathematics, that's actually why it's called geometric. But for now, we'll just stick with the facts, and let's label this formula. Good news, has a lot of the same labels. A sub n will still be the nth term, whether we want to find the 5th term or the 20th term. Yep, a sub 1 is the first term. Here's your common ratio, probably the most important part here. R is your common ratio. And well, maybe I'll take that back. Perhaps the most important part is the fact that, again, I have an exponent. And so I just want to highlight that. Yes, the letter n is the nth term, but the entire exponent, n minus 1, just something that we're going to want to be aware of. We're going to have to very carefully do that, probably with our calculator. Okay, but yeah, not to be too redundant, we'll have to work with that exponent. Ready to try the formula to get the 5th term? Now remember, the 5th term we already found is 324, but let's sort of test it with the formula. So if I'm trying to find the 5th term, that's a sub 5. My first term was 4, kind of can see that up in the list. We found that common ratio to be 3, not too tricky right now. But then I get a little n minus 1, which would be, oops, not 4 minus 1, but we're trying to find the 5th term, so it'd be 5 minus 1. Yeah, 5 minus 1 is 4, and perhaps I was a step ahead here, but we're going to end up with 3 to the 4th power. Now, on your calculator, 3 to the 4th power, you're going to want to use your little exponent button. Most of your calculators, that's like a little caret top key. Okay, try that. Do 3 to the 4th. Make sure you can get 81. Notice that we actually do that first. And then 4 times 81, that's pretty easy. That's going to come out to 324. Are you familiar with that exponent button? It's right here on your calculator. It looks like a caret top. All right. You want to try the 20th term on your own? Or do you want to kind of do it together? You decide. It's a lot of the same things, except this time it's 20 minus 1, which is, of course, 19. Now, it's going to be 4 times 3 to the 19th. A little sort of calculator help here. You could just type that in from left to right. You could just type 4 times 3 to the caret top 19. And trust me, it's going to do the order of operations correctly. Okay, it's going to do 3 to the 19. It's actually going to do that first, and then it's going to multiply by 4. And you do get a big number. Maybe it's not a surprise to you that it's a big number because you got this exponent of 19. How many digits do we have in this number? Quite a few, I believe. 10 if you're counting. So that's 4 billion. Of course, and some change, but the 20th term is going to be really big. And this is typical with a geometric sequence that we see that there's a lot of change when we start to journey away from the first couple terms. All right, now, if you're having trouble with your calculator, it's something that you could, of course, ask me in the classroom. You could seek out a little extra help with a good AI tool. But do you want to try on your own here, these two? Same thing. I'll help you get started. You can pause the video if you want. Because really the first thing that we want to notice, that's right, we want to notice the common ratio. Now, sometimes it's just easy enough to see that the numbers are changing by being multiplied by 2. But if for some reason that was hard for you to see, remember you can always take the next term divided by the previous term. And just so we're clear, we could do that with any of the terms that we want as long as it's the next term divided by the previous term. And most definitely the R value is 2. Set up the equation. Try to find that 12th term. You're going to need the first term. You're going to need your common ratio. It's going to be an exponent of 12 minus 1, which is actually an exponent of 11. Remember, as we've said a couple times, you can put this right in your calculator. 4, you can hit the times key, 2 caret top to the 11. Just type it on in, and you get 8,192. How about this last example? Yeah, your common ratio, well, if you take the next term divided by the previous term, it's coming out to be 0.5, more commonly thought of as a half. Yeah, it's kind of like you're multiplying each number by a half. Or you could say that you're dividing by 2. All right, well, we just want to find the 8th term, so we're going to use that geometric formula. We need the first term, we need this common ratio, and we need an exponent. 8 minus 1, we need an exponent of 7. It's going to be 20 times 1/2 to the 7. As I've said a couple times, you can type that in. Okay, well, think about it. If you're dividing by 2, if you're multiplying by half, numbers are just going to keep getting smaller and smaller, so it may not be a surprise that we end up with this strange little decimal, which is actually 5/32. You can write the answer as a decimal, you can write the answer as a fraction, but the eighth term is going to be pretty small. Okay, this would be a good opportunity to just summarize something that's true about a geometric sequence. And before we finish for today, of course, we're going to actually do the remainder of this paper tomorrow, but before we finish for today, are you able to do a little bit of comparing and contrasting between both arithmetic and geometric? Make sure you take a moment and consider that. And then in class tomorrow, we actually will pick up with the back side of the paper. Something I'm excited about for class this year is the multiple opportunities that you're going to have to take learning and extend it. Now, I know you say, that sounds really exciting, Mr. Naylor, but seriously, we're trying to grow you. We're trying to help you to take what you've learned and apply it to some new ways. And, we're sitting in a math classroom, and that means we got to try to do that with math ideas. So I really want to encourage you, when we get to new things, whether it's in a lesson, maybe it's with some independent homework, that you actually try to figure out the problem. Don't just stop. Don't just type it into AI, but see if you can figure out what's something that I do know about this problem. Maybe you can't finish it. Maybe you end up starting it and realize a little later, oh my gosh, I almost did finish the problem. Or maybe the best thing is I got the problem right. We're asking you to try. And so here's 3 problems. And if you were sitting in the classroom, honestly, I would say try something with any of these 3, with one of them, 2 of them, maybe all 3 of them. Yeah, there would be quite a bit of time here where you're expected to figure something out with each of these problems. Now, in a video, it's a little hard. You don't get to hear what people are saying around you. I can't see what you're doing, and I can't maybe point you to the next step. So the best thing I'm going to do in the video is try to show you the things that you could have figured out, and then take it and try to finish. So how about this first problem? Perhaps maybe the first thing you notice is just that it's different, right? You're trying to find the first term. So I don't know what the first term is, but let's not get too worked up about what's different. Let's see if we can figure out something that we do understand. It's arithmetic, so what's that mean? It means there's going to be a common difference. That's right. Maybe I should find that common difference. 124 is the 78th term, and then the 79th term is 135. Is it true that the common difference, that they change by 11? I can't see why it wouldn't be true. I have the 78th and then the 79th term. It's a geometric problem, so I should be able to use that geometric formula. Remember how that formula works? We're going to say that the nth term is always the first. Oh, there it is, the first term. That's what I'm trying to find. Okay, and then, well, wait, maybe I can actually plug some things in here. Like, for example, what if I want to use the 78th term? What if I say that I know the 78th term? Why am I getting so hung up about that? Well, that means that I can plug 78 in for n, right? Now, just so we don't miss it, I don't know what the first term is, so I'm going to have to put an a sub 1 in that spot. But the whole point here is that I do know a lot. I know the 78th term. I can put in 124. I can put in 78. And the only thing left is this common difference of 11, right? And of course, I found that, and I can plug that in. Now, some of you, the only thing that you're asking is, why didn't you use 135? Well, here's the honest truth. I could have used 135. That means, though, that I would be using the number 79 right here. And just so we understand, we would end up with the same final answer. But I'm going to just do the problem with 124, because I want you to realize here that what we really have is an equation. Yeah, it's an equation. 78 minus 1 is 77, and 77 11s is 847. So I have 124 equaling a sub 1 plus 147. Think back to your algebra days. We're going to continue to use these concepts this year. Yeah, I got to solve this. I got to actually subtract 147 from both sides, and that leaves me with my first term. Does it make sense that it'd be negative 723? Well, if you're only at 124 at the 78th term and you got to go backwards, back to the first term, it's going to be down there in that negative, as a negative term. It's going to be negative 723. What do you guys think about the second problem here? We're trying to find the first 4 terms. I'm given the formula. Now, it's a geometric formula, but I'm given that formula. Do I need to like find the common ratio? Well, I don't know if I really need to find it. I think it's more like that you just want to identify it. There it is. It's 4. But maybe I have to more realize what it is what we're trying to find here. Yeah, we're trying to find the first, second, third, and fourth terms. So check this out. That means that I'm going to plug in n. I'm going to plug in 1 for n. I'm also going to plug in 2 for n. And really, I'm going to go down here and end up plugging in 3 and 4. I got myself 4 little problems that I can do with my calculator, or I can kind of do with knowledge that I have. Just so you can see what's going on here, I get an exponent of 0. Maybe you remember from algebra that an exponent of 0 is always going to cause the value to be just 1. So this is basically 3 times 1. Well, I hope that my first term is 3. That's what the formula said. Oop, all right. How about this one? Exponent is really just 2 minus 1, which is 1. Well, that's 3 times 4 to the 1. That's basically 3 times 4. Right, that's going to be 12. Are you finishing it up? Plugging in a 3. It's going to give you, whoops, too many 4s. It's going to give me 3 times 4 squared. So it's going to come out to be the same as 48. And the last one. Oh, what's that you're saying? Of course, I can't really hear you, but I'm wondering if you're saying, Miss Naylor, I could have done this a different way. How so? How could you have done this a different way? Maybe we could have used the formula to get that first term, right? The first term is 3. And we could have used the formula to get that common ratio of 4. And if I just keep multiplying by 4, oh my gosh, if I just multiply by 4, I could also come up with a list of my first 4 terms. All right, well, both ways are good. Honestly, completely correct. So sometimes when we're doing an extension problem, there might be a couple different methods. How about this last problem? Have you gotten to it? How about now we take a look at it? We're trying to find the 5th term. Now, it looks like I have the first, second, third, and fourth terms. That's kind of handy. All right. What should be the first thing that I'm noticing in this problem? What's that? That's right. I'm trying to notice if this thing is arithmetic or if it's geometric. Oh, wait, this is like the first time that nobody's told me. Okay, so how do I know? Well, honestly, you have to kind of go through the choices. You know, are the numbers changing by the same difference? Am I adding or subtracting the same amount? If I go from -6 to 12, just kind of by the way, those numbers I would have added 18. Is that what happens when I get to the next number? Do I add 18? No, it doesn't seem to be really making sense with addition or subtraction. Is it going to make sense with multiplication or division? Well, it looks like the first numbers, if I multiply by -2, okay, so I could get to 12. And then what if I multiply by -2 again? Yeah, I could get to -24. So it has to be geometric because there is a common ratio. It's that R value of -2. Now, since I'm only looking for the 5th term and I have the 4th term, could I just multiply by -2? Most certainly. That'd probably be the easiest thing to do. I have my answer, I have my 5th term. But yeah, I could plug into the geometric formula. First term, common ratio. And then if it's the 5th term -1, if I like using my exponent button on my calculator, I could type this all in. It's -6 times -2 to the 4th. I would definitely use parentheses in a time like this. When you have negative numbers, you definitely want to put them in parentheses. But is definitely going to still come out to be negative 96. All right, well, the next logical thing is to try some problems. That's going to be pretty common after we have a lesson. So you've got 5 problems that you can start looking at now. And I would imagine that in our next class period, we'll be practicing this concept of arithmetic and geometric sequence.